And so now we will go into pipelines. So we're actually going to ignore this part, ignore ETL. So we're going to go ahead and start into pipelines intro. So if you guys go through the curriculum, you'll notice that basically it's a very short amount of pipelines. So I'm going to give you a little more information. We have about like a little over 15 minutes. So I think it'll be enough to kind of get through the concepts. And then we might have I'll show you guys an example one before we kind of head out. But pipelines are basically like this way to automate the way you do like ML, okay? And so what's really nice is basically, it can basically build the whole data science life cycle or data science process. So you imagine from like data acquisition, cleaning data, up to feature engineering to modeling, basically can do that whole process and put that in one pipeline. And what's really nice is one, it makes your life a lot easier. And two, you actually can bring this out into deployment. So basically you can pass this pipeline along and they can make it more efficient and stuff like this. And it's basically all the steps you take. So note that basically pipelines can really make your code really neat, and we'll see an example of like how this can really help you. And it can do the whole process, but of course you have to make sure it's like a proper pipeline. You don't want to just be able to stick the whole things together and things will like technically you can write a whole bunch of things in pipelines that won't technically work. So you have to always be careful. So kind of reiterating advantages, reduce your complexity. Basically you can focus on each part of the pipeline at a time. So imagine, think of like data acquisition to cleaning data, to feature engineering, to modeling. You can basically take out sections of that pipeline and replace it with something else. It's like, oh, you know, like this cleaning step is flawed, or like, oh, there's some new, you know, step we need to do for cleaning. We can go ahead and take that part of the pipeline, replace it, and basically have it continue all the way through. So it makes it nice and easy. It's convenient. So kind of like, again, saying like you can summarize all of your fine detail steps into a pipeline. So that way you basically say, okay, here's my full pipeline versus like, you can imagine like a full notebook. So you can imagine like you might do like the notebook by hand, and since like trying to like do the steps of like cleaning, exploration, feature engineering, but then you would summarize all your steps into a pipeline. So you can either do that at the very end, or, you know, what would be really great practice is as you're doing each part, you're adding it to the pipeline. And as you add it to the pipeline, essentially, all you need then, someone doesn't need all of your steps going through your notebook. They just need the full pipeline structure, and they can just do that part, okay? And it's flexible. Like I said, you can also apply it if you have new parts to your model, or like, you know, new data, you can basically change it out, and it's relatively easy. So if you now have a huge amount of data, you can just say, hey, here's my whole pipeline, and that will work hopefully on that whole data set. Or if you need to modify parts of the pipeline for that different data set or model and stuff, you can kind of do different things with it. So again, really useful. Again, one technique that's really useful for pipelines is grid search. So when you do grid search, you can actually pass in the whole pipeline rather than just the single model that you're training. And we'll talk about what grid search is in a little bit. Okay. And then prevent mistakes, which is actually really important. So one big issue, which we haven't talked too much about, but is data leakage. And so if you remember back when you do like your train test split, one issue that can happen, whether you're doing the training or into testing, or you can also do like your train validation, is that the validation and like your testing really shouldn't be used. Like the model should never see that information until basically you test it out, right, or validate it. And it's really easy to accidentally give information that really it shouldn't have. So what you can do with pipelines, you can make sure that structure stays in place, and you can really separate out the structure and the actual testing and validation from each other. So you don't have to tie it directly into there. And we'll talk a little bit of what that looks like when we talk about grid search. Okay, cool. So this is kind of like the overall advantages, what pipelines kind of are. Any questions about like why you would use pipelines over basically just typing out yourself?
So how often do people do this versus like doing it themselves? Is it very
Yes. I would say it's really common when you do it in industry. So when you're working like in a job, it keeps your code really nice and clean, because a lot of times what will happen is that a data scientist, you might explore different parts, and then you give this information to maybe another software engineer or machine learning engineer that can take your information and process it into a more like actionable, you know, like set. So like you can imagine like baking it into like an app, or baking it into a website or an API and stuff like this. This can also be you, depending on like your role as a data scientist. You might also be partly that role where you're doing this part, and you can technically like write this whole stuff. You write this beautiful notebook and analysis, and then you have to say, okay, now I have to actually make use of this, and that can be a huge pain. Where pipelines simplify that process a lot more.
okay?
So I think it's really important as like an industry kind of thing where if you're doing things in production, they call it, you likely will be writing a pipeline.
Okay.
Okay. Cool. So it sounds kind of, hopefully it doesn't sound too scary. So we'll kind of see what this looks like. So I'm just going to imagine like doing like a pipe, like doing this process from beginning to end, right? Or not beginning, basically like, taking in the data. So we got the data already. And then cleaning it and then, passing it over to our model and stuff like this. So a very simple pipeline. So note that we technically don't have to use like a pipeline class, which is built into scikit-learn. You can technically do this yourself, but you'll see in a second that how much more work it'll end up being. So note that I'm just going to import these different classes here. So we've probably seen most of these: standard scalar, PCA, random forest classifier, simple imputer. Imputer basically is a way to replace missing data automatically. So normally what you do when you do cleaning your data, you might kind of see like what things need to be replaced, and you might use something like an imputer essentially to figure out what things need to be replaced after it. So you can pass in certain hyperparameters saying, hey, replace it with the median or replace it with this value. You can kind of pass in that part in there. Usually this will be done after you do your exploration. Okay, so I know it's kind of a new one that most of us haven't seen yet. And then just note that I'm just getting some data, again, our good old iris data set, because I've nice and small. I don't have to worry about it too much. And I'm just doing my test train split. So note that we're basically going to train it with one set and then test it with the other set. Okay. And then we'll see what this looks like without the pipeline class. So this is actually still going to be pretty streamlined, but even then it's going to be a lot more work. So the first part right here is going to be basically doing our transformations on the data set. So we usually call these transformers, but basically you can imagine it like adjusting the data set. So we have the original X-train data, and we want to do things like replace the missing values, scale down the data, so standard scalar, right? So its mean now will be 0, its standard deviation will be 1 for each of those features. And then PCA, basically we talked about this, basically finding those nice features. I can also put like n components here, like and decide which ones, but I'll just do PCA in general. And then we'll also have our classifier, right? Our random forest classifier. So note these are all like ready to go. Nothing's actually happened. I'm just creating these different objects ready to like actually do stuff with it. And so you can imagine here, this kind of like this whole steps we're doing. The first thing we're going to do is basically take that imputer and basically find all the missing data, and take X-train and basically fill in all that extra missing data. So we'll call this X-train filled. Okay. In this case, I'll tell you is that iris data is not missing any information, but this would be kind of like what the steps you would do. Okay. The next part basically is we're going to standardize the features, right? So we're going to do standard scaling. We're going to take those things that are already filled, we're going to pass it in, and we're going to call this X-train scaled. So now all of our data has gone from like some values to like some value that's probably between like, probably about 5 and like -5, like some kind of scaling, right? Depending on like what the data set looks like. And then I'll pass that information, the scaling, into our PCA fit transform. So remember, this is going to create basically using PCA. If I had PCA with n components, it would scale it down from like, let's say 4 features down to like 2 features. But in this case, it's just going to create 4 new features, but it's going to be by order of importance. So this will help also most algorithms do a better job in finding the right answer. So I get my final X-train reduce. So this is my full data set right now. It's just kind of been transformed a lot. And then the final step is to train it, right, on the model. So I have my random forest classifier, and I feed it in my X-train reduce. And then of course I have my Y-train, which is basically what the actual labels are. And that will basically fit it on here. Okay. Any questions on how I kind of perform all these parts?
When you said for the PCA, it would bring it down to 4, is that because that's the default?
Right. In this case, yeah, iris dataset has 4 features. So in this case, it will just do the default of like whatever the number of features are that started off with.
Okay.
Mm-hmm. Cool. All right. So that's our common practice. So basically I have it all trained and fit. So my classifier is now trained and it's learned all the information. Then to actually do any prediction on this, well, what we have to do is we have to do the same transformations to the X test data. Note that it means that I have to, I didn't do the scaling in the transformation and stuff like that on the X train and X test at the same time, because that would create data leakage, where essentially is that your classifier at the very end here would kind of essentially know a little bit about the full data set. So it's kind of a subtle point, but this is why we have to also use that transformation after we train the classifier. So now we have to do the transformation on the X test. So you can see the same steps: imputer, standard scalar, PCA, and then we're passing in our X test, right, reduced, pass it into our classifier that's already trained, and we're going to predict off of it. So we get the Y prediction. So just kind of show you guys that's what it does, right? And we could then evaluate it and stuff like this. Note that basically if we needed more steps, like, oh, we also want to do another imputer, or we need to like do some extra steps, or we want to do some other scaling or other feature engineering, we'd have to fill this into here, right? And we'd have to fill it into here. So this thing can get very, very long depending what your process is, right? And note that it's very easy to accidentally like to skip over this part, right? And pass in like scale, and you would have to like say, oh no, I messed this up. And you could maybe create your own functions to do this and stuff like this, but you can imagine this is starting to get a little bit of a pain. So this is where pipelines come in. So I'm gonna do the same process, but with pipelines. And this is the code right here. So you can already see it's a relatively like straightforward. There's a lot less typing that I have to do. And basically this pipeline here from scikit-learn, I create this pipeline, and basically each part here, and we give it some kind of name. You can name it whatever you want, but something hopefully descriptive. And you basically say what it's gonna do. So in this case, it's gonna take a simple imputer, then it's gonna take the standard scalar, then do PCA, and then do classifier. Done. So now if I want to fit it, right? So like just like right here, we did the dot fit, we can actually fit with the whole pipeline. And this dot fit will basically pass in all the data from X train all the way through here, train the random forest classifier with the Y train data. And note that I didn't have to do any extra thing. Basically just passes the whole pipeline. Then here's a really cool part, is if you do a prediction, well, I can take the same pipeline, right? This is basically just like structured pipes. There's no like classification here. But basically because I already fit this random forest classifier here, this will know, like, oh, when I do dot predict, it will predict off of the trained random forest classifier. So basically I don't have to do any extra thing like I did over here where I have to do the whole transformation. This will do the transformation and will only do it with X tests. Okay, cool. Makes sense? So you can already see that this makes this part much smaller. Basically you only have to do it once right here, and you can modify this however you want, and then just change the fit, or basically just pass in the fit and predicted. Okay. Any questions? Cool.
So far, we've only been using existing scikit-learn classes. If I wrote my own class, could I put it in a pipeline?
Yes, that's what's really cool about this. So there's some really cool things, and I'll actually show this on using a pipeline with, I cannot pronounce his name. The one who wrote the hands-on, hands-on machine learning with scikit-learn. Jenny, I know you know how to pronounce it, so. But
Mr. G, we'll just call him Mr.
Mr. G. Oh, I like that. Oh, that sounds like me though. No. But yeah, no, we'll go with Mr. G, right? Good old Mr. G. Anyway, he does a great job showing this a little bit, and like how you can create your own class. You can basically modify these different parts. There's a whole bunch of things you can do to combine pipelines together into this numerical and categorical and treat those separately. Or you can do things with natural language processing where you count how many words there are and where they occur and things like this. Pipelines are so flexible, but also like really useful in that way. So you can basically create like so many parts in this. There's so many interesting things you can do. Okay. So kind of showing you guys what this looks like. I will talk about parts of pipelines. I realize I only have 5 minutes, so I think this will be, are you guys okay if we go a little bit over, just so I know if anyone has to head out? Okay, I don't have anything planned after this, so maybe we'll go a little bit longer. So parts of the pipeline. So this is, note that I'm gonna talk about estimators, transformers, and predictors. There are also things like, for example, feature unions that I haven't mentioned about in here. Maybe we can talk about that in the future. Basically, one thing you can do essentially is connect two pipes together. So you can imagine you have a pipeline just for numerical and then a pipeline just for categorical. Combine them together and make that as one part of the pipeline and continue forward. So basically, I'm using this pipeline from scikit-learn, which is really popular, really flexible, really useful. And here's a documentation for you. You kind of see a little bit of like how they use it and everything like that. So that's a little link in there. But basically, one thing we can do is that we can break it up into different parts. And the pipeline object basically allows you to take in other classes. And most things are going to be basically an estimator. And we've actually been using a lot of these estimator transformers and predictors already. We just haven't given it a name. So now we actually could say, oh, this is what they actually are. So the first one is the estimator. And basically know that pretty much any object in the pipeline is an estimator. So basically it means that it takes in data and estimates, or you can think of it as learning information with some parameters. So those parameters would be like hyperparameters. So for example, an estimator, the imputer here is an estimator. So you can see we're taking a strategy of median, but also this right here, the random forest classifier, is also an estimator. So basically it's going to take in some data and learn from it. So that's kind of like the idea of like when we say it's training. So note that basically pretty much everything we've been using is an estimator whenever we think about like, using those like capital, classes from scikit-learn. Okay. So some usage methods. So every estimator has a method called fit. And basically this fit method is just essentially saying, give me data and I will learn from that data. So you can imagine on a standard scalar, it's learning from the data that you feed it. You feed it in data and it's going to learn, oh, this is the maximum, this is the minimum value, this is the standard deviation, this is how I should transform this information. So note that this isn't actually transform, it just learns from whatever information you give it. You can also give it other parameters, which are hyperparameters. Basically, parameters are used to tweak that learning process, right? Okay, so note that basically every estimator has this fit function, or fit method, I should say. Okay, cool. And from this, we'll stem off into two different parts, transformers and predictors. So a transformer is basically an estimator, but has a little extra thing that we can do to it. So a transformer basically, it will take in that dot fit information, right? Learn from it. But then what it will also do is something, it will transform data. So you can actually feed in it some data. So let's say, like, oh, here's your training data, learn on this for a standard scalar or something like that. Basically say, okay, this is the minimum, this is the maximum, the standard deviation. And then we can do a dot transform, which we'll see in a second. And that will transform whatever data you feed it. Okay. So note that basically there's a new method. So every transformer has a dot fit method, but after we do the dot fit, we can do transform, and transformer will call that method and apply that transformation to whatever data set you give it. Okay, so note that you have to do the dot fit first, and then you do dot transform. Okay, so what's kind of cool is that, well, since we're going to usually do dot fit, dot transform for transformers, the transformer actually has a built-in method, and this is actually, you can define it yourself if you make your own class, called fit transform. And basically the idea here, I won't read this whole thing off because I don't think you guys can read this later kind of deal. But basically the idea there is that we can either do dot fit with the data set and then do dot transform with the data set, and that would kind of do your whole process. Well, if you're going to use the same data set for the fit and the transform spots, we can basically do a dot fit transform. So fit underscore transform, and that will take in that data set, learn from it, and then transform the data set and then return that part. Okay. So what's really nice about,
why do you want to transform the data?
I'm sorry?
Why do you want to transform the data?
Yeah, so you can imagine like if we had like min-max scaling. So we want to basically say the minimum is like 0 and the maximum is going to be 1. It's going to learn what the minimum and the maximum are, but then it's not going to do anything until we do the transform, where we say, okay, give me back that data set and let me transform it from 0 and 1 to the very different parts of the data. Does that make sense?
Okay. So scaling is an example.
Yeah, exactly. Okay. Yeah, and this is where if we do dot fit and then do transform, fit transform usually tends to be a little more efficient. So by default, it'll at the very least just do fit and then transform, which would be the same thing as you doing dot fit, dot transform. But certain methods, or if you define it yourself, can actually be a little more efficient in how it figures out how to transform this information. So it can be a little more time efficient and space efficient if you just do fit transform. So if you're going to use the same data set for fit and transform, you should probably just call this method. Okay. Any other questions? Cool. All right. So the last one here is going to be kind of, you can probably take a guess, it's predictor. So this is going to make predictions off of whatever you trained it. So remember, we're going to use the dot fit to basically train it to learn about information in the data set. And then we can do a prediction method to basically say, okay, give me some, based on what you've learned from your dot fit method, go ahead and make predictions on this new data set, or it could even be the same data set. But the point is you feed it now a new data set, not a new data set, you feed it a data set, and it will make predictions based off what it learned with the dot fit method. Okay, and so you can imagine if we have the predict like we had with, can I show you guys real quick, this dot predict right here. All right, this is basically going to say, okay, like me taking this now, this X test, and predict it from whatever it was trained on previously. Okay. Also, note that predict methods also tend to have a dot score. And so that's kind of nice that basically you can use this as a way to evaluate your method. So, or not evaluate your model, or your predictor, I should say. And so this kind of gives us a way, what's it called? A way to kind of assess like how well your model performed or your predictor performed. Okay, cool. All right, so I'm going to very quickly just kind of show this. I actually had I'll show you guys what this looks like first. So Mr. G here, oops, his book, he has a second edition here, but he also has a little repo of an end-to-end project, and actually uses housing data, knows this whole thing, and I'll kind of just very briefly show you how long this is through the whole analysis. So this is kind of like if you imagine if you were to do your Mod 1 project, that's what he's doing right here, except he actually is using pipelines. So I believe, here we go. You can see a little bit of how he does this kind of pipeline going through here. I think he ends up using numerical, and then he also does some other things. For example, he's creating his own new transformer where basically he does just the numerics, just the categorical, combine them together, and he does finally making predictions. I mentioned about that feature union here, where basically he's combining those two features. Basically think of like that numerical data, that categorical data, combining it together, and then in the final part, basically making a prediction with the pipeline that he created. Okay, so note that you can just run this directly in Google Colab. I think I've shown you guys Colab before, right? So no, basically it's like Google Drive, but like for Jupyter Notebooks, which is just amazing. It's free. You can also connect it to, if you're gonna play with this, you can see when I went back to it, I clicked run in Google Colab, which is a nice little addition he added. But you can also import your own notebooks into here. But you connect it to a runtime. Note that if you're gonna run these notebooks, especially for machine learning, you will go to runtime, change runtime type, and make sure you do GPU, or at least GPU. And this will allows parallel processing and some more efficiencies, especially as you get more complex models. And you'll see it start connecting, and then you can actually run it directly on here. Now, I will say is that I did run this notebook just to kind of play around with it in Colab. There's one part where basically he will do something called grid search, which we'll talk about in a second. But if you do this, my notebook ended up running for about an hour. So just kind of know, basically, just going through all those different parameters, it's going to take, basically has to train each individual one. Also with cross-validation, which is what you want to. So just kind of be aware is that if you want to run this, that you might have wait for a while, but you can kind of play around with it a little bit and do all those things. Or what you can do is just go ahead and like fork this, or go ahead and download this repo, and you can play around with this parts. Okay. And he has a pretty good job of, I think, explaining each kind of like more or less like what he's doing, so you can kind of see how he's going through, and I think you can follow it more or less. Okay, cool. So that is pipelines intro. Oops, yeah, we'll leave that. Okay. So any kind of quick questions before I move on to grid search? Cool. Yeah. So a really efficient way kind of like to logically organize your code and like your whole data science process. So one advantage of this, I mentioned, was grid search. So I'm going to show you that one.